is Kubernetes security. His topic is going to be Kubernetes security, what you need to know. He's been an instructor for many, many years across many different technologies. I worked with him, here at ExitCertified for a long time. We even worked together in the past. Yeah, we worked together for many years. The session is being recorded. You may have just heard that mentioned, and you should get a recording within a day or two. We usually send it out to everybody who registered, so you'll have access to that recording, and you'll probably also get an email follow-up. I'll talk about it a little bit at the very end of the presentation. We currently have a summer promo, which gets you a pretty good deal on training courses. And so I'll talk a little bit about some of the Marantis courses that apply to this topic, and a little bit about that promotion at the very end. And like I said, Mike Stapleton is he's a Kubernetes expert. He's been working in IT for 25 plus years, I think. 30. Oh, wow. That's, yeah, okay. A little more salt than pepper there. Yeah. Okay.
A little bit of fake darkening. Yeah.
Yeah. All right. Well, I'll let you take it away, Mike. And like I said, I'll be manning the chat.
Okay. Well, thank you very much, Miles. Yeah, my name is Mike Stapleton. I'm, as he said, we do not have time to talk about me. So we're here to talk about Kubernetes security and what you need to know. All right. So this is an overview. In 45 minutes, we don't really have time to go into all the details. There's a lot to talk about here. So it's going to come pretty quick. We'll hopefully have time at the end to answer questions and stuff like that. If not, hey, I'll probably put up my email address at the end and you can send me emails. So let's dig right into that. The agenda. So we're going to start off with a refresher. Yeah, hopefully you're not totally new to Kubernetes. You'll get a little more out of this, but we do got to make sure that we're kind of all in the same place. So we'll start off with a refresher. We'll talk about the 4 C's of cloud native security. You'll see what that is when we get to it. The API server. So Kubernetes has a API that everything goes through. We need to do authentication, authorization, and well, how does that all work? Networking security, both from the cluster level and within our actual services running in our pods. Containers, how containerized are things, right, in Kubernetes, and what are the issues related to that? Secrets management. So your credentials for your applications, where are they and how do you manage that? Content trust, your images, the actual executables, right? I've seen a lot of articles recently talking about Kubernetes security problems, and actually most of them were just people running applications on Kubernetes that had security problems. So how do you protect yourself from that, right? You don't want to be running images that will have known vulnerabilities and things like that. So we got to talk about content trust. And then by the time we get to that, you'll see there's a lot of things that you need to do right to have as secured as possible Kubernetes cluster. So wouldn't it be nice if there was some tools you could run that help you discover anything you missed, right? So we'll talk about compliance and validation. And finally, Miles will talk a little more about some of our training and certification offering. And seriously, Kubernetes is complex. There's a lot of things. So training, yeah, probably a good idea. All right, so the architecture. So just a big view here. We're showing a Kubernetes clusters. We have some nodes in here. We have worker nodes, master nodes. We got some separate machines running the etcd databases. This is kind of our cluster. You can see there's a firewall around it. Kubernetes by default. And when I say default, I mean built-in default, because it depends on your particular Kubernetes you're running and who configure it and how they set it up. But the built-in default really relies on border security. So make sure that it's not, these machines are not hanging out on the internet. That like bad, they're just not good for that. So we have a cluster of machines. The what we call the control plane are groups of machines and processes that are running Kubernetes itself. So all the processes for monitoring and launching your pods and all that. We have the worker, that's our data plane. Typically, we have more workers than masters, but this is kind of a minimum viable HA cluster. We got 3 of everything. The reason for 3 is mostly because of the etcd database for high availability issues, and that's a security issue. It uses a majority consensus algorithm, which means you need 3 to be able to stay up in the event of a failure. So we typically end up with 3 of everything at least, and then more. Now the API server runs on these masters. So we usually have, well, you're going to have a load balancer in front of the API server. So we can see we got a load balancer in here. And yeah, we're firewalled off from the whole world. Our etc database should be talking to nobody except the API server. And for management purposes, yeah, you should be using some kind of a bastion host or a jump host. And so you connect there, and then from there you use your tools, for example, kube control. Right? It talks to the API server, and you can configure and monitor and do what you need to do there. In addition, for your applications to be exposed on the internet, you're going to want to use an ingress controller of some sort. We'll see that later on quickly. Yeah, that's basically a reverse proxy that you configure to expose things. And that's just a, like I said, just a quick look, or at least one view of the architecture. Right? I'd like to take this opportunity to talk about the controller pattern. Kubernetes, if you're familiar with it all, or you looked at it a bit, you'll hear about controllers. Controllers do everything. A controller is a piece of software running somewhere that registers with the API server for events. If something happens, it goes off and does something, right? It's asynchronous event-driven programming model. What happens is something makes a change through the API server. The API server goes through its processes to mutate, validate, and authentication, authorization, all that. And if it make it through all those steps, then it gets written to the etcd database. And that's a change, that's an event, that's something that happens. And then the API server will notify all of the controllers that care about that event, and then they can go off and do something. This is a fundamental architecture inside Kubernetes. It's also why if you do something wrong in the command line, as long as your specification, your templates are valid, you won't get an error, but then you come back and things aren't running because the controller had a problem. All right. So it's, well, makes troubleshooting a little interesting, but it's an important pattern. You can make your own custom controllers to react to events, and they could be security events, there could be all kinds of things. Right? Typical example is an ingress controller. So I mentioned to expose our applications, we typically use a reverse proxy. But how do you manage the configuration of the reverse proxy? An ingress controller. Kubernetes does not come with an ingress controller. You need to select one and install it. So your mileage will vary, and security issues and how you tune things, how you configure things, it depends on your particular ingress controller that you install. But the basic idea of an ingress controller is it actually configures some kind of reverse proxy. Right? So an example of this pattern is an ingress controller. It watches for changes to objects of kind ingress. If you make an ingress object template through the API server, it will see that event, and the specification in that ingress object is the proxy configuration rules. So it'll see those configuration rules and it'll use it to configure the reverse proxy. It also will monitor other objects like services so that it can keep track of changes to your backend pods and stuff like that. In the end, the reverse proxy is sending traffic to your pods. Right?
So Mike, would you say that the ingress controller is part of the control plane? It's kind of a weird, it's hard to say that question. It's the reverse proxy. I don't know.
Yeah, I guess you would. I would. I never really thought of that, but yeah, I would consider part of the control plane.
Okay. I thought it was an interesting question. I was like, I don't know.
It is interesting. Yeah. Absolutely. So yeah, an ingress controller effectively is just a reverse proxy that uses the controller pattern to manage its configuration. Very convenient. And again, important point here, it depends on your particular ingress controller that you install. So watch out about that. All right, another little look at the network architecture, just kind of like processes and who talks to who. So we have our API server, everything goes through the API server. So that's really significant. The command line, the controllers, everything. We make changes, or controllers or something makes changes through the API server, and that gets persisted again in the etcd database. That's an event. The controllers can be notified. So there's something called a controller manager. It has all the built-in default controllers. And as I said, you can run your own, and they could be running as pods on the cluster or off the cluster, as long as they have access to the API server. Scheduling for scheduling. The workers, yeah, Cubelet. So Cubelet's a big guy for security here. It has an API that the API server communicates with, and by default, it's not secured. It does not do authentication and authorization. All right. So the networking between your master processes and your workers needs to be secured. We'll see some ways of doing that in a bit, but that comes back to what we were seeing there earlier, border security. Right? If you are doing some kind of a cluster where you have some nodes on the cloud and maybe some on-prem, yeah, is that whole network connection, someone can launch anything on there? Well, they might be able to talk to the, Kubelet. That's a problem. And for example, you can exec things into your containers. Right. Pods, well, that's your applications and your containers. They talk whatever protocols they want. So sure, they can do HTTP and a little bit of inter-process communications on the nodes themselves. So yeah, you got also, as a remote, we're talking about Kubernetes security here. Of course, these are just operating systems, typically running Linux, could be running Windows. They got to be secured. I'm not going to get into OS security right there, but absolutely, if someone gets access, root access on one of your worker nodes, no, don't allow that to happen. All right, the 4 C's of native security. What the heck is that? Well, sure. So if you look at running some containerized application, well, you have the actual executable code that comes from the images. So that needs to be vetted and scanned, monitored. Make sure you're running the right code, latest, updated, patched. Again, it is containerized, which simply means you have processes executing your code and Linux kernel features have been applied to it to contain it, to restrict it, to isolate it. That needs to be configured appropriately. That is configurable in Kubernetes. When you create a pod specification, you say, hey, run this pod, you can make it more contained. You can apply greater security, greater containerization, more kernel features to it, or less. If someone can create a pod and you don't do something to control the specification of it, yeah, they can basically launch some processes on the nodes that they're running on that have root access. They can access the whole node. So you absolutely have to control who do you trust, what do you trust to create pods, and have some way of enforcing configuration of those pods. More on that in a second. And then, of course, those containerized applications are running on a node, a cluster node. So we have to worry about the networking in between the nodes and everything. And then that's running on some kind of a network, right? So maybe it's a cloud. So the cloud APIs and everything have to protect it. Anyone who can, delete your cluster, right? If you're using a managed Kubernetes service. And so you're only as secure as your weakest link. And this just gives you kind of an overview of all the different places you need to consider. And of course, we're just kind of looking at the Kubernetes part in the middle here, but you need to think outside of the box too. While we're talking about security, just a general reminder, right? We want confidentiality, not hide your data so people can't see the data being sent back and forth. Integrity, sometimes a little less obvious. You can't just encrypt data. You also got to protect it so it can't be changed because that's a vulnerability. And availability is a security issue. Think of denial of service attacks, right? So if your services go down either on purpose or by accident, everything needs to be fault tolerant and scalable. So you got to consider all of that at every level, right? Some of the principles to think about is like the least privilege principle, which just means anything should only have the privileges and access to do what it needs to do when it needs to do it. So you don't have root access if you don't need root access, right? Reducing surface attack, hiding. So hiding and removing things. So don't run things you don't need to be running. Don't have tools that you're not using. Minimize everything possible. And then of the things that you do have, they should be hidden from, firewalls, basically, right? Make it, and you got to do it everywhere, as I said. Right? Anyway, you get that. That's just basic, right? Okay, as I said, the details depends on your deployment. Kubernetes is a framework. You plug in how you want to do networking, how you want to do monitoring, so your mileage will vary, let's say. So yeah, like if you install Kubernetes using Kubeatom yourself, it's going to be very different what you have as opposed to Google Kubernetes engine or Amazon EKS or something, right? So everything I'm talking about here, check your details. It depends, right? That's kind of an annoying thing. So for example, the networking, how networking works, if you've looked at that in Kubernetes, it's hard to figure out. And the reason is because there is no built-in default way that networking works. If you use Kubeatom to set up your cluster, maybe you install a networking plugin, Calico. Well, how actually networking works and what security features are available and how you tune things will be very different if you use Calico compared to, let's say, Amazon Web Services has a VPC CNI, they call it. It's a different network plugin. It works significantly different. So you got to check the documentation. So you got to know your cluster. They're not all the same. Depends on who's set up and what they plugged into it, right? The authentication for the API server, authentication is typically, if you're using a managed cluster, it's integrated with the cloud provider. Again, check with their documentation. If you're using a managed service, absolutely check. If you're doing your own Kubeatom on-prem or something, well, there's a lot of options there, right? As I said, no default logging or monitoring. You're going to need those things. And there's no default UI, which personally, it's not always a bad thing. Again, we want to minimize, right? So reduce the attack surface. Watch out about your tools. Any tools, you got to protect those as well. That's often how you end up with security problems. People get access to the tools and then they get access to the cluster. Yeah, check documentation. Kubernetes is not secure by default. Got to say that, right? If you really need to isolate things, you really want to look at having more smaller clusters. Envisioning having one big Kubernetes cluster and just running everything on it is going to be problematic. You have to go out of your way to isolate things and secure stuff from inside the cluster. For example, all pods can communicate with all other pods and any processes running on the nodes by default. So there's that border security. Inside, everything can talk to everything, right? As I mentioned, the actual data plane and control plane communications isn't fully secured by default. And check with your deployment. Containers, as I mentioned earlier, also containers are just processes that have Linux kernel features applied. Which ones? Right? By default, very little, right? Compared to what you could do. Anyway, pod spec aside, so anyone that can create a pod can reduce it, right? Containers can use all the resources on the node. By default, there's no limits. It's not VMs, right? So there's no limits on the amount of CPU memory. So any one process in any one container on a node could take out the whole machine. Right? So yeah, denial of service attack on purpose or not there. So if you really need to isolate things, run them on separate nodes. Scheduling can help with that. The etcd database, where it stores all of our configuration for everything, and significantly, it also stores our secrets, which is used for credentials for our applications. It's not encrypted by default, and it's not backed up by default. There isn't a backup tool in Kubernetes if you just install it raw yourself. So you need to take care of that database and protect the data. And last but not least, it'll run anything you tell it to run. Right. Absolutely. All of these things can be addressed. And that's what we're going to look at, how you address them. But these are problems that you need to look at and be aware of, right? So that's what I'm saying. It's kind of an overview, but I'm going to dig into these. So starting off with the API server, right? So the API server, it has another type of controller that's really, 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 really significant here. They're called admission controllers. There's two types of them. There's mutating admission controllers and validating admission controllers. Anytime anything is making a change through the API server, the API server will do authentication, authorization. So you have to be figure out who you are, and then based on who you are you allowed to do what you're doing. And then it goes through the mutating admission controllers. These things can change your template. If you've ever created something in Kubernetes, you'll notice that if you create it, you have your template, so you have what you configured. If you then retrieve that configuration, you do a kubectl get, there's going to be a lot of stuff in there that you didn't set. Mutating admission controllers can change the template. This is a key way that we enforce security. As earlier we talked about pods, and I said in the specification, we can reduce security by basically running privileged containers and giving them full access to nodes. Well, not if we have a mutating admission controller that's adding or validating those security settings. So mutating can change it, validating just can say yes or no. So they can deny, no, not going to do that. Right? And then finally, if you make it through that, then it gets persisted to the etcd database. And then the other controllers, the more common ones, then they actually they go off and do, create the pod or whatever it is, the template that you created there. So yeah, mutating admission control is really important. There's a bunch of built-in ones we're going to see. And again, you can create your own. All right. So step number one, the API server authentication. There's no users in Kubernetes. Basically an authentication module, which is pluggable. There's a whole bunch of built-in ones, and it does support webhooks. So you can integrate with some external identity and access management system. It resolves to a subject. A subject is either a user with groups or a service account. It's just a name, right? So if we go back here, we got the authentication and authorization. The authentication part just says, yeah, this is John, and he belongs to the group test and dev. Then the authorization step uses that information to decide if they're allowed to do what they're doing. So there's no users that are pre-created in here. Another little security issue in here, yeah, anonymous access by default, again, depending on your deployment. But the built-in default is anonymous access is enabled. So if you don't provide some kind of authentication information when the request is coming in, and you can see we support a whole lot of stuff built in, paired tokens, OpenID Connect. You can have a proxy server in front that adds the credentials as HTTP headers. You can do basic auth. If none of those authenticate the user, then they will automatically be a user called system anonymous who belongs to a group system unauthenticated, which by default doesn't have permission to do anything. Just it's not that bad, but that can be turned off. And for security purposes, I would. The other subject type is a service account. A service account is something you create. It's in Kubernetes. So it's an object type that gets persisted in the etcd database. When you create a service account, it creates a secret, and that secret has an OpenID Connect token in it. So if someone uses that OpenID Connect token to authenticate to the API server, then they will be, their subject type will be a service account of that name. And then under authorizations, we can say, well, if it's this service account, it's allowed to do X, Y, and Z. So that's the idea of service accounts. Authorization. So once you're either a name, and also there's UID in there as well, and or an array of groups that you belong to, again, just strings, or a service account, then we have to decide, are you allowed to do what you're trying to do? Webhooks are supported, again, for integrating with your own identity and access management systems. The API server can basically do an HTTP post to your external server saying, hey, this is John belonging to these groups, and he's trying to do, creating pods. Are they allowed to do that? And your server can say, no, whatever you want to do. So that's convenient, but you'd have to create those. The built-in way of doing authorization is role-based access control. With role-based access control, we create roles. Roles list privileges. And so a role is a list of what you're allowed to do. It's only allows. And then we need to associate a role with a subject. This is through what we call binding. We bind a role, which is a list of privileges, to a subject. So if someone authenticates as that subject or service account, type subject, right? then they will have the privileges of that role, and many roles can be bound to the same subjects. Right? Really important key thing here is the binding part. We have what's called a cluster role binding and role binding. Cluster means it's cluster wide. So for binding, if you use a cluster role binding to bind a subject to a cluster role, you are giving them whatever those privileges into any namespace across the, so anything within the cluster. Right? If you use a role binding, something that doesn't have the cluster name in there, then that's created in a namespace, and you are only giving them whatever privileges in that role or cluster role that they're bound to just within that namespace. Right? So role binding grants permissions within a namespace, whereas cluster role binding grants it cluster wide. So yeah, we can restrict who can do what within a namespace. That helps isolate. Right? So that comes along with the least privilege idea. Here's an example, just a quick one of RBAC configuration. So this is, again, kube control. It's in the etcd database. We have a role, could be a cluster role. This would work as well. And it's since it's a role, it's in a namespace. Cluster roles just aren't. Other than that, they have rules which specifies what you're allowed to do. So in this example, the things you're allowed to do, you can do get, create, and list for pods. Cool. So you create that. Then we need to associate it with a subject, and that's through a binding. Now we're using a role binding, so that's in a namespace. So we're just going to give some subjects access to whatever they're allowed to do in the role just within that namespace. So the namespace is development. The subject is a user that resolved to the string pquigley. So pquigley will be allowed to do pod, get, create, and list within the development namespace. And that's because of the role reference. So we've, pquigley with the role called pod create. That's the binding right there. Right? You can see it's an array. Could be a bunch of them. Now, if this is the only role bound to them, then yeah, they'll only be able to do that in that namespace. There could be other bindings that give them more, access. That's kind of an example of the built-in role-based access control. Yeah. API server, another important thing is auditing. You want to make sure you know who's doing what, when, where. That is configurable. You need to create an audit policy file on the API server. So wherever your API server is running, you create a policy file, and then there's arguments to the API server that specifies the name of the file. Inside that policy file, you control the level and what is audited. Right? So you can increase auditing, you can only audit certain types of events. That's all configurable. You also tell it where to log to. And kind of two built-in options is a file on the API server, or you can have the API server do HTTP posts of the auditing events to an external server. That's a good idea if you can do it. Bottom line is make sure you are doing auditing and that it's off the machines somehow. So if you're doing it to a log file, you're going to want to mount a volume or something there so the data is off the machines. Again, if you're using a managed Kubernetes service, check with their documentation. They might already have it, integrated with their like CloudTrail or something if you're on Amazon. All right, networking security. Yeah, pod networking. So again, all pods can communicate with each other. Not good for least privilege. So we can configure what are called network policies, basically a firewall. So you set up firewall rules that allow only certain pods to talk to other pods. That mileage will vary again, depending on your network plugin. So check with the documentation for your particular network plugin and your Kubernetes cluster to see whether they support it or not. So just creating a network policy doesn't mean it's actually firewalling anything. So test. Right? Host networking. When I create a pod, I can just say, host network true in part of its specification, which means it's now just a process sitting on the TCP/IP stack of the node. It's hanging out on the network. It can use local host to talk to any other processes on that machine. So again, you're going to want to control that. So when pods are being created, don't do that unless you really, really, really need to. All right. Now, to help with security, there's some other things that you can add in here. The ingress controller, absolutely. You don't really just want to use port forwarding, another option with services in Kubernetes to expose things. Ingress is much more flexible for sure. Another idea is a service mesh. So there's service meshes that support Kubernetes. I think probably all of them now. Examples would be like Istio or Linkerd. A service mesh, the basic idea is that instead of your components, your processes running in our containers and our pods, instead of them talking directly to each other, they send everything to the service mesh. So it centralizes the configuration and management of your network traffic, right? Now, the actual architecture, the traffic won't be, it's not a bottleneck or anything. So take a look at your particular service net mesh on how it actually works. But from a management standpoint, it gives you centralized configuration and control of everything. So that's really powerful. So using the service mesh is probably a really good idea. It's much more flexible than just doing network policies because it can do things like logging and monitoring and metrics. Yeah, they're pretty darn cool. Take a look at it if you haven't. Example, Google Kubernetes Engine, GKE. One of the options is just a single checkbox. Hey, Google, create me a Kubernetes cluster. And by the way, I want Istio. And it's installed. So again, check your documentation. Definitely something to take a look at. The cluster itself, the nodes. As I mentioned earlier, not all communications is secured between the data plane and the control plane. If you have an unsecured network in between the nodes, then originally what you could do is you could set up what's called SSH tunneling. It's supported by Kubernetes. Check Kubernetes documentation. They have a new service called the connectivity service. It effectively does the same thing, except it's instead of just using SSH daemons for tunneling the traffic, it uses dedicated processes to do that. Basically acts like a process. The data plane is your worker nodes. All right, so where your worker processes, and the control plane is the all the processes for Kubernetes itself. So yeah, Istio is a service mesh. Just let you know there. Yeah, check out Istio. It's pretty cool. Yeah, connectivity service. Again, documentation in Kubernetes. For sure. Also, another little detail: the API server listens on localhost. And any traffic coming from local hosts, so from the same machine, well, same TCP/IP stack there, and it'll just accept whatever. There's no authentication. Authentication authorization is bypassed by default. So this is a good reason not to let your API server just run other things on it, like pods. So if someone runs a pod on the same machine that's running your API server and they use host networking, well, they can just talk directly to the API server and bypass your authentication authorization. Yeah. A worker node is just the name for a computer that runs our, right? And when we talk about data plane, we're just talking a higher level, where we run our processes and everything.
People are having fun with your typos on control plane versus pane.
Oh, okay. Yeah, I just noticed that. I'm dyslexic.
And then plane, PLAIN.
Yeah,
it could be ANE.
Whoops.
Control plane is actually an interesting one.
I think I should leave that. Anyway, whoops. Yeah, I suck. Yeah, cluster networking. Other little issues here, like I mentioned, the Cubelet is not secure by default. So if someone can talk to the Cubelet port it's listening on, I forget 10,000 something off the top of my head there. Yeah, they can do things like exec into your containers. So yeah, got to hide that. There's command line arguments to Cubelet. The defaults are anonymous auth flag true. So they're just command line argument anonymous auth. It's set to true, and authorization mode is set to always allow. Those are the defaults. So if you change those, you also have to reconfigure the API server because now it has to authenticate. So you got to change these things at the same time. Yeah, make sure people can't talk to the API server directly. They can't talk to Cubelet directly. Watch about any tools you're using. Make sure you secure those as well. Right? Firewalls everywhere. Yeah, the containerization level. So yeah, if you can create a pod, you can do the specification. If nothing's stopping you, you can run processes like root. That's the bottom line, right? How containerized settings within the pod specification is something called a security context. It can set defaults at the pod level or more details at the container level. Either way, security contexts are used to increase or decrease how containerized something is. By the way, they don't work on Windows. Just saying. Right? Pod security policies can be enabled and used to enforce constraints and defaults on your security contexts. And so you can say, no, we don't support host networking. Nope, you can't do privileged containers. Nope. By the way, you have to have these default security settings. Right? That's all in something called a pod security policy. As soon as you enable that, you have to create security policies and apply them using RBAC to controllers and users that want to actually create pods. As soon as you enable this feature, no one can create pods. Nothing can create pods. It is, well, deprecated. So it's been deprecated and they plan to remove it in 125. So its more featureful replacement is basically using something called OPA Gatekeeper. OPA Gatekeeper is a mutating admission controller, among other things, and you can use it to validate and mutate the security context along with all kinds of other things. Right? So that's looking forward. Or presently, something to take a look at. Currently, it's still beta, but it's being used by a lot of people. Much more featureful, whereas security policies were just for pods. I guess the only thing I really liked about pod security policies is as soon as you enabled it, you were secure by default, at least as far as the security context configuration. Yeah, native's pretty cool too. Yeah, I'm not mentioning everything that's out there. Like I said, this is an overview and give you a good idea of these are some of the more common things, I guess. Yeah, resource controls. I mentioned, if denial of service. So pods can, executables running in our containers can take out the whole node it's running on. So if you need to protect things from each other, you, in the end, need to apply resource controls. But even if you do resource controls, like the basic resource controls for like CPU and memory, there's more kernel resources than that. So if you really, really need to isolate things, then they really should be running on separate nodes. This is scheduling. So part of your configuration is telling the scheduler, by the way, I want these things on separate nodes. The ways we can do that is in your pod spec, you can create what's called a pod topology spread. It's configuration that are hints to the scheduler or commands, configurable, saying, hey, run these over here. It's related to nodes. It could be related to just run them in separate availability zones on a cloud because I don't want to have all my pods running on nodes in the same availability zone. So if I have a failure in my cloud, I lose all of my processes. That's one way. The other way, a little is kind of newer, a more original way, was pod affinity and anti-affinity rules. Again, this is in your pod specifications. They, again, can be used to say, run these things together or run them apart or run them on certain nodes. Using your pod topology spread or affinity rules, you can use that to run things together or separate. So definitely take a look at those. So yeah, scheduling is complex. There's lots of different ways of accomplishing the same things. We also have what are called taints and tolerations, or basically we can poison certain nodes so they will not run certain pods. For a pod to run on that node, it has to have certain tolerations. So we're saying, yeah, don't run these on those machines. Taints and tolerations. Pod topology spread, one of its benefits is you can actually set defaults for it. It doesn't have to be configured into each and every pod specification, whereas affinity rules do. Again, you could use a mutating admission controller or something to enforce those if you needed to, or to validate it. Another issue, resource controls, is your ephemeral storage. So by default, you create a container, they have a read-write layer. If your processes are writing just to a local directory, it's using up space on the node. So a process that maybe is creating incredible amounts of logs for some reason could fill up the root file systems on your nodes if you don't have that data, on separate volumes and things, which typically nowadays we don't. So yeah, that's another way that could take out the machine. One way to address that is a setting that you could do is a read-only file system. So we can set a read-only file system on it, and well, now it won't be able to actually, it'll be denied. So that helps. There are some mutating controllers you're going to want to look at. Limit Ranger. You create configuration objects for the Limit Ranger mutating controller, and it'll set default and enforce max and min resource controls. So, max memory, max CPU, those kinds of things. Definitely going to want to set that up. Quotas, another mutating controller. Whenever you go to create things through the API server, we can validate, you don't have too many of something. Quotas can be used for total amount of memory. Right, so Limit Ranger is cool because you can enforce certain CPU memory limits and constraints on our pod specifications, but then you can create as many pods as you want. So then, so if you want to control the total amount of memory or CPU across all the pods someone can create, well, then you can use quotas to do that, or just the total number of pods or the total number of something. Right? These guys work also at the namespace level, so you can have different configurations in different namespaces. Right? And there's a new feature coming out, working on, I'm not sure if it's out of beta or anything, but anyway, ephemeral storage limits can be configured as well. So anything that's creating data that's being written onto your nodes. Just ephemeral, just data written to some directory on your nodes, and when the pod goes away, it gets wiped. That's what we mean by ephemeral. The etcd database, where are your credentials kept? Yeah, it's not encrypted, it's not backed up. Check with Kubernetes.io for how to set up encryption, and there's lots of training as well to help you do that. But by default, if you just did kubeatom, it's not encryption at rest and it's not being backed up. So make sure about that. Now, very useful idea for your credentials, at least, is to integrate it with some external secret management solution. Right? Kubernetes secrets just, you put the credentials in it and you're done. If you need to update credentials or something, you have to do that all yourself. So for example, like HashiCorp Vault, you can, it's a secret management system. It'll help rotate your secrets and secure them and help you manage them. The big one is the rotating of the secrets and everything for you. Another example for Amazon, if you want to integrate with Amazon Secret Manager, they have a secret store CSI driver. It's not crime scene investigation there. It's a container storage interface, and basically a plugin for volume management. It can be used to integrate credentials management with AWS secrets. And there are others out there. You don't want to look at that. Right? Hey, content trust. Yeah, so integrity of your images, right? Don't use the latest images for everything. That's a whole nother issue to get into, but you're going to want to make sure that your images are up to date. Vulnerabilities are discovered. Some ways to do that is can be done maybe by a registry. So for example, Maranta Secure Registry, it can scan your images every time you're uploading them or reading them and notify you of any known vulnerabilities. Another example is Amazon's Elastic Container Registry. It supports scanning as well. Another thing is, if you don't have that, well, Trivy. Trivy is more of a command line tool that you can use to scan images that are in a repository that doesn't. Right? So you might want to take a look at that. Either way, you want to look for vulnerabilities in your images and keep them up to date. Now, signing, another issue is you would prefer not to just run any image, right? That can be a problem. So you would like to validate what's in your images, maybe have security sign off on it, and then somehow configure your cluster so it only runs images that have been digitally signed by your securities personnel. So we're not just running anything. One way you can enforce that, again, with an admission controller, is there's an admission controller called Connoisseur. And yeah, it'll validate that the pod spec, whenever it tries to run something, it's running a digitally signed image based on your specifications. And again, OPA Gatekeeper, well, yeah, it can help make, it can configuration, so image configuration as well. It can help validate that as well. So yeah, you're going to see more and more about OPA Gatekeeper for sure. There's an awful lot of moving pieces in here, so yeah, how do you know you didn't miss anything? Compliance validation, we're almost there. Yeah, you're going to want to have some tools that you can execute that will look for known security vulnerabilities, and you're going to want to run this on a regular basis. So for more details, yeah, check with the Center for Internet Security. They have a whole lot of documentation and benchmarks. Some of it you got to pay for, some of it's free. A free tool that you can run that actually runs these security benchmarks is Kubench, open source free tool that you can run. It'll run these benchmarks. Benchmarks is in compliance and validation. When I hear benchmark, I'm thinking, well, give me performance statistics, but no, it's going to look for misconfigurations. Let's put it that way, right? So you're going to want to run something like that on a regular basis. And yeah,
Can't believe you did it. So I was talking to Mike before the session. I thought, well, you got a lot of ground to cover. It is an overview level, right? And so if you want more information on Kubernetes security, obviously going and taking a course is probably the right way to do it. Now let me switch, and I will start driving from my slides. And so let's talk a little bit about some of the certifications that are out there, especially around Kubernetes security. And then we'll get into some of the training that's available. And Mike can comment on these things as we're going. But if you're looking for Kubernetes certification, it's the CNCF, the Cloud Native Compute Foundation. They've got 3 different certifications. The newest one is the Kubernetes Security Specialist, what they're calling the CKS. It's definitely the newest cert. To do that one, there's an exam that you have to go in and do, but you first have to have the CKA. That's by far the most popular of these certifications, the Certified Kubernetes Administrator. So the CNCF is, a large, body that certifies a bunch of different things. There's many companies are part of that foundation, including Mirantis. And these are the 3 vendor agnostic Kubernetes certifications that they have. They have one for application developers. They have the main one for administrators, and then this newest CKS.
They're tough certifications.
Yes. Yeah, they're very tough. And the CKA is, what is it? It's performance based, right?
They all are. Yeah.
Yeah. And that's what makes them. It's not just a multiple choice kind of question. You have to have some muscle memory in, creating these things, provisioning them, there's some troubleshooting even on the CKA. I haven't done the CKA, so, I'll ask you, Mike. So these are very difficult. And they're not it's not like you take a 3-day class and say, okay, I'm ready to go and do the, certification exam. It's not those kind of certifications. But certainly training will help you in getting ready for it. And I mentioned earlier that when it comes to Kubernetes, ExitCertified partnered with a company called Mirantis. They're a cloud native company dedicated to helping developers build and ship code faster, right? ExitCertified is partnered with many vendors, but that's the one that we prefer for Kubernetes training. So Docker, Kubernetes, OpenStack. I've created this Mirantis learning path document, which sort of outlines, some of the different offerings. But most of the Kubernetes for operations people or for developers, they kind of start the same. There's a 1-day Docker containerization essentials. And then from there, you can go into like a 2-day Kubernetes essentials. And then it starts to diverge if you're going to be in operations or administration versus development. And we have some 5-day bundles where you save a little bit of money if you sign up for the 5-day class rather than the 3 individual classes. And that's sort of, where we would expect you to know before you go and maybe take the CN 320 to get ready for the CKA certification, right? Once you have your CKA certification, there's our newest class is the Advanced Kubernetes Security. So a lot of the topics that Mike talked about today are covered in that 2-day class. Of course, in 2 days, he can go in a much deeper than in 45 minutes, right? So, he was going at a furious pace and not going too deep, but that's exactly what we do in that class. And of course, that will help you prepare for the CKS. As I mentioned, there's other training that Mirantis has. They have their own cloud native platform. And so, you mentioned the Mirantis Secure Registry, so if you're a Mirantis customer, then we have some other classes that might be more specific for you. And then they also, do a really great job of OpenStack training. So we have those available too. So this, actually, let me throw this link in the chat just so you can take a look at it right away, unless somebody already did that. Did somebody do that? No. Okay. So let me just throw that in there. Yeah. And I'm sure we'll send this, in a follow-up email as well. But if you get a hold of this PDF, these are all, hyperlinks. So if you click on the CN 330, it'll take you to our website where we talk about, this class, and here's the upcoming date, September 30th. This class is, the most common ones are the initial classes. So this is a class that might only run once a quarter, on our schedule. So the Kubernetes security, like I said, it's brand new class, and it is, not everybody's going to be taking the security class. So it's a kind of a more rare one. But if you go back and look at, say, the CN 100 or something like that, if I view the schedule on that, we have these classes running, September 20th, October 4th, November 1st, so it runs much more often. So that's some of the training that's available. I mentioned that we have a summer promo on right now. It runs until August 27th, and it's the promo code is summer500. And basically, the idea there is you can save $100 on a 1-day course, $200 on a 2-day course, up to $500 on a 5-day course. We also will give you, if you've got group that you want to send. So we have public classes where, if you're just going to send 1 or 2 people from your company, you would do that. But if you've got a group of people, we also do private training, right? And, generally it's virtual. But, as things start to open up more, we can send an instructor to you, we'll see what happens with that. But the nice thing about the private training is, we have a little more leeway to say, okay, well, we want to focus on this area and not so much on that area. You could maybe tweak the times. Normally our classes run sort of, 9 to 5 kind of. But we've done really crazy things with the private classes where we do a half-day class over 2 weeks instead of, so there's a lot of options there in the private training. One thing about the summer promo, you have to register by August 27th and take the course by the end of September. So that's sort of our current promotion right now. And like I said, if you have any questions about training, you can send those to me. Let me just put my email address into and I'll probably put you in touch with one of our salespeople. But if it's just a question about what's the right course kind of thing, you can send that to me. And, like I said, we can build like a cross-vendor, kind of path if we need to, and really figure out, well, hey, our people all know Docker, but they don't know Kubernetes. Well, then we can skip that first class and start in the second class. So, I can work with you and figure that out. We have a couple minutes left. I think, Mike, you're not in a rush here. We don't have to run out right away. Nope. So if you have any further questions, you can throw them in the chat. and we'll take a couple minutes here to answer. I think we've answered most of the questions along the way. Yeah, I don't think we had any outstanding. What is ingress? Oh, well, ingress. I mean, in terms of Kubernetes, are we talking about the ingress controller? It controls requests coming in, right?
And ingress is an ingress, it is confusing. An ingress is a type of object that you can create in Kubernetes. Oh, yeah. So you have a template and its kind is ingress, and it represents configuration for a reverse proxy. An ingress controller reacts to that specification in an ingress and configures a reverse proxy. Generally, when we just say ingress or ingress controller, they're just talking that you have some kind of reverse proxy. You have some kind of a controller that's configuring it through Kubernetes objects of some sort, and it's used to expose your pods to, outside the cluster. Yeah, inbound traffic. Yeah. Mm-hmm. Can explain Istio. Yeah, service meshes in general, they've been around for a while now. They help solve a problem of the fact that when we do networking, we configure how things communicate to each other and how they authenticate and everything all over the place. If you ever done any troubleshooting with highly networked things, you got to go from node to node to node to figure out who's talking to who and what's going on. It's, everything's just blasted across your space. Everything's all over the place when it comes to configuration of networking. So any changes you need to do, you need to figure out where you got to run around and do it. The general idea of a service mesh is it centralizes the management and configuration of your networking in one place. So you can, the traffic, now everyone's configured the same way. Where do you send your traffic? To the service mesh. And then the service mesh will worry about getting the traffic to go to the right place. And it can then do things like monitoring and metrics and authentication authorization. It can do all kinds of things. They're just very, 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 it's a cool thing. Yeah. And Istio is one example of that.
Yeah. And you would say that these are important because of the architecture that we use with microservices, where there's a lot of inter-process communication.
Yeah,
and,
exactly.
And the explosion of that communication really said, hey, we need help.
Yeah,
here.
Tons of small interconnected processes running on different machines. Yeah, how do you manage the networking for that? Yeah, service mesh helps.
How about this question? How can we get TCP dump from Kubernetes cluster?
In the OS. So you log into your nodes and you do TCP dump. Remember, in the end, it's just processes running in Linux, if you're a Linux host. So you still have all your normal tools and everything. They're not VMs, So yeah, just regular TCP dump.
How about this last question? Do we have the MITRE ATT&CK framework supported for Kubernetes?
Never heard of it.
I'm not familiar with that one.
No, yeah. Doesn't matter how long you've been doing something, there's always something new. Yeah, it's a new term for me. Let's see. MITRE ATT&CK. Yeah, I don't know. I guess that's the right answer. I have no idea because I'm just looking it up now myself.
How about this one? If a pod has deleted, how will take log for deleted pod? Okay, I'm not sure exactly what they're asking here, but I mean, one of the things you mentioned was that, we want to redirect any kinds of logs to sort of an external place so that, those individual nodes, if they get destroyed in some way, we still have the logs elsewhere, right?
Mm-hmm. Yeah. And then, and of course, like with the audit logs, you'd like preferably to be proactively monitoring the logs with some kind of intelligent software to notify you of. But that's totally outside of Kubernetes.
Yeah, I certainly don't think you want to log anything to the ephemeral volumes. That's the exact opposite of what we want with logs. All right. Well, it looks like things are slowing down. Mike and Miles, thank you very much. Yeah, Mike, thanks for your time. That was great.
Yeah, no problem.
And like I said, we're going to be sending the recording of the presentation. We may also send a PDF of the slides because there were some links in there that you might be looking for. You might have to clean up those spelling mistakes first, but we'll get that all to you in the next few days. I'm not sure how long the recordings take. Probably a couple days.
Wasn't me. Someone hacked my slides.
Yes, that's right. All right. Well, thank you for your time, and
thank you, everybody.
Yeah, keep your eyes open. We've got lots of webinars on lots of different topics. We probably run 2 to 3 webinars a month at ExitCertified across different vendors and different technologies. But we're always looking for ideas of what to do webinars on. A lot of times it's an important topic. Very often it's like this one where there's a lot of detail, and so it's tip of the iceberg. And if you're interested, then hey, I want to take this security class with that guy Mike Stapleton. And so that's kind of why we do it, is to let this is what you can expect, but in a more intimate setting where you can ask a lot more questions easier. And so that's ultimately I think what we do really well. So thank you for your time today. And yeah, I'm not sure about the chat. Oh, I think if you want the chat, you can actually
save it.
Yeah, if you click on the ... there's a save chat. And so you can save that. Somebody at the very beginning mentioned they had a link to the NSA's report on Kubernetes security. I was flipping through it as Mike was going through, and it was a lot of the same. Oh, you don't have the ... option. I guess the save chat in webinar style, we don't have the save chat. Well, it may appear in the recordings. I'm not sure how that works. But like I said, you've got the links will be in the slides, so we'll get those to you. Do you have any plan for Kubernetes on Azure? Yeah, well, Azure has a managed service called AKS, and that is covered in some of the Azure classes that we offer. Right-click, select all, and then copy. Vadim's got a great solution. Yes. Oh, there, Mike shared a file. I don't know if you can save that file or not, but that's the save chat. It's probably got my message.
It's only my stuff. Oh,
yeah,
I didn't catch it. That's no good.
Yeah, that's not good.
Oh, and you know what? I sent the wrong file too. Anyway, it's okay. So that's not going to be
all right. That's not good.
That was
Control C does not work.
Duty. Amazon training. Whoops.
It's downloadable, but it's not the right. It's not the right file.
Well, it's going to be one of those days, I tell you. So ignore my last.
All right. Well, I'm going to stop the share, and I think Michelle.